typical theorems that you have to be able to understand and use. And we're going to kind of go through each of them. Now, the difficulty arises, it's easy to spot them. The difficulty arises when they put, say, 5 different ones in one particular question and you're trying to see the specific, shapes that you're after, okay? Because you're looking for specific things for each of these questions. So our title is just circle theorems, okay? So if we write that down, good job, Jaden. And we're going to just start with the terminology. These are the circle theorems here, okay? So we've got angles from 2 radii. Actually, that's not technically a circle theorem, but it's something important that you need to be aware of. And then these are our circle theorems here, okay? So if we go down to terminology and draw yourselves a nice big circle, first thing that we're going to draw in is a tangent. You can tell me what a tangent is. It is a line, a curvy line, a straight line. Ari, you want to expand on that?
Isn't it a straight line that goes through the circle?
It goes through the circle?
Yeah.
So, for example, like that. Is that a tangent?
Yeah.
Like that?
Yes.
Okay, I'll give you a clue. Neither of those are tangents.
Is it like a
Is it on the edge? Is it on the edge of the circle?
Like
Touch the edge of the circle, yeah.
Okay, that is a tangent, okay? Because it has to touch the circle once, okay? It touches a curve at one place, okay? Yep, draw it, please. And we're going to write a tangent. Yes. Go ahead, yeah. Yeah. A tangent is a straight line that cuts or touches a curve once. Okay, so it does not go through the circle, it touches it once, okay, at one place. Now, what is, if I draw, you can tell me what the name of this line is called. Am I going too fast? Alright, what's the name of that line?
Is that a chord?
It is a chord, good. I'll put this one in and then I'll let you catch up. I'm not going to put in radius or diameter because I'm guessing we all know what radius and diameter are, yeah? Just quickly remind me what a radius is. Half the diameter, what's the diameter then? Yep, a straight line that goes from one side of the circle to the other, but through the center point. That is a chord. C-H-O-R-D. All right, so that is a chord. What is... let's do some coloring in. If I was to color all this part, you should know this because we did this this term, we done this term, we did this term. What is all this called? Good, Ari. Is Ari the only one taking part today? So that is a segment. Yeah. I'm going to draw another circle just to put in a few extra things so that one doesn't get too busy. That is definitely not a circle. Oh, and that is not either. Circle. And on this one, I'll put my center point. And I'm going to put two lines. Okay, I said I wasn't going to draw these in or label them, but I might as well. So each of those lines are the radius. Yep. Good, right. And I create a sector, so that's a radius. And the colored stuff in here that I will color in. This is a sector. And you should all know how to work out the sector of a circle, yes? Not very good at coloring. Could never get it in between the lines. Practice makes permanent. So if let's call this angle theta. You can, let's label this first as well. So this is a sector. Who wants 10 bonus points to tell me how you work out the area of a sector? Yep.
You take the ratio based on the interior angle and the total angle, which is 360. You can find the ratio and apply that to your total area to find that middle section.
Yep. So if we are dealing in, so that means if you're dealing in degrees, yeah? So if we're dealing in degrees, it is, you said, the ratio of the angle that we're after out of the whole thing, which is 360. Multiplied by, what's the area of a full circle? Yep, pi r squared. Now, if you are dealing in radians, what is 2 pi? Yep, good. So if we're dealing in radians, the 360 part becomes 2 pi, because remember, 2 pi radians is the same as 360 degrees. Good. Yep, times pi r squared. And what can we do here then? With this? Good, cancel out the pi's. So I'm left with theta over 2 times r squared. Yep, we did this at the start of the year. Do you remember, Lily? Good. All good tomorrow? Now, if it's all about the colours today. What is this called? No, don't do this to me. Come on, just work. This line is called a what? From there to there. We'll do it a bit heavier. What's wrong, Marco? Oh, sorry, Marco. What colour should I?
Did you even draw anything?
What's a good colour for you? I can pink. This one? Okay, so this, what is this called? What is that called?
Can you see it, Marco?
Yeah, I can see it, but I can't do it.
An arc?
It's called an arc, right? Good.
Yeah, I was gonna say that.
No, it's called it's a specific arc. Is it the big arc or the small arc? So if it's small, it is the minor arc. Good. So, whilst we're at it, how do you work out the formula for the length of an arc? Let's say we're working in degrees. Kate.
You know, like the same process as before, but you use the
Yep. So if we're working in degrees, arc is equal to theta over 360 times pi d. I prefer 2 pi r. Okay, and then we can simplify that a bit because I've got 2 on the top, 360 in the bottom. Theta pi r over 180. Now, if I'm working in radians, the formula for the arc is, what happens at 180? And then 180 becomes pi, so theta pi r over theta. The thetas cancel out. Sorry, yep, the pi's, thank you. So the pi's cancel out, and I'm left with theta r, which is a lot nicer to use when it's in radians. Is that all ringing bells?
Just the one for the, only for the minor one.
Yeah, because we're looking at this angle, so we're dealing with this arc. Yeah, that's fine. Radii, as in 2 radiuses.
Wait, if it's 3, what was like radii?
No, just radii.
I know, but I like radii.
Okay. Now this is, like, you'll see this, and it'll be self-explanatory. But the trick is remembering it when it comes up in a test, because there'll be so much more information on the diagram that it's easy to forget these little straightforward ones, okay? So put in your radius. Let's draw it this way. Okay, so put in all the details. Let's call this O. B. And let's say that angle AOB is equal to, it's not very well drawn. Actually, it doesn't really matter. Let's say 98 degrees. Find angle OAB. Any thoughts? Marco?
41 degrees.
Because?
And that's also trying.
Excellent, okay. And that's the thing, it's straightforward, it's nice to, it's easy to recognize, okay? This is a radius, this is a radius. So these two lengths are exactly the same, okay? So these two angles, yep, have to be exactly the same. So I can do my 180, subtract 98, which is 82. and then I divide that by 2. Yeah. So angle OAB, so OAB is 41. Technically, yeah, it's wrong. You want to define the angle by the 2 legs, okay? So this is O to A and then A to B, so it's the angle in between those. Okay, so the trick is just realizing it's an isosceles triangle. They can make these a bit more difficult by doing the following. Can I put it down to there? I'll put another one on this side. I'll try and make the circle a bit smaller. Sorry? Yeah. Yeah. We'll label it. And let's say that this angle is 28. Sorry, can you see that okay? So angle OAB is 28 degrees. Let's say find. Oh, there's actually 2 ways that you can do this, but let's just do it the way that we've been doing it. A, C, B. So I'm after this angle. So this is the one I'm after. You tired, Jaden? That is the thing. You want to find as many angles as possible, okay? You just... these questions, I often start them just trying to find out whatever I can, okay? I'm not necessarily trying to find this one first, ACB. I am just interested in finding as many as possible and then hope that that one turns up. What did you find first, Kate?
I put the other 28, and then I found 124.
Okay, good. So you put the other 28 because this is an isosceles triangle, this one and this one. So this triangle is isosceles. So this is 28. So 28 add 28, 56. Subtract it from 180, and you get 124. So this angle is 124. See? And then, yep, so because these 2 angles on a straight line have to add up to 180, so yep, this has to be 56. And then again, I've got then another isosceles triangle on the other side. With this side is the same length as this side. So this is 56.
It's 1.4 divided.
Yep, it's going to be, yep, 180 take away 56 is 124. Divide it into 2 and I get, did I say that right? 62.
I just know it's 62 because of the minus, but then just add those two and calculate them.
Right, now where's the 90-degree angle, Ellie?
Um,
Okay, at A, B, C. Now, did anybody else realize that?
yes, but I
Good, that is also a 90-degree angle, okay? If I go back to our, that is Thiel's theorem. I don't know if I pronounced it right, okay? Exactly, yep. Two chords connected by the diameter meet the circumference at 90 degrees. So you could just do 90, add 28, take it away from 180, gives you the 62, okay? Which is a nice way, good for recognizing that, those of you that did, okay? But we'll cover that as well. All good? Good, so that is the first one. The next one that we want to look at is angles in the same segment. Is it okay if I go down to here? Marco, you good? You got everything? Oh, yes, okay. I got a nice box around it. Who knows? All right, so your angle's in the same segment. I'll come back to that in a second. Draw out your triangle. Put in our center point. Marco, if you want to watch the rest of this later, yeah. So you get caught up and you know everything that's going on.
Bye, Marco.
Bye, Marco. All right, so angles in the same segment. Now, it's important that you realize that these lines do not need to go through this center point, okay? Which is why I deliberately not put them through it. It's kind of like a wonky bow tie.
Oh, for some reason I was thinking of TIE Fighter.
Or a TIE fighter, yes. Okay, now with these, this angle in here, it's the same as this one. See, Marco? So I could say angle D O equals angle O D C.
It looks really weird.
It can look pretty funky, yeah. Show me. That's fine.
Wow.
Now, also at that same reasoning, let's use a different color, let's use black. By that same reasoning, then this angle here is the same as this one. Okay, and like these things are not difficult. But it's just when you're met with a lot of them in one question. So that's angle A.
So A and D are the same and B and C are the
Yes. But just to be clear, Lely, B and A are not necessarily the same. Okay, it's just the two black ones are the same, the two red ones are the same. Lely, what's this angle called? Don't say C. What's it called? Label it for me. Or this way. Doesn't matter which way around you do it. You could no, so I want you to name it like this, okay? Because you keep calling them like by C or by D. Okay, ACD is fine, okay? She's called it ACD. That's fine because this is the same part of the line, okay? You could call it, if you wanted, OCD. You could call it, what's another? Because you're starting from this point. Okay. What else could you call it, just out of interest? DCU. DCU or DCA. Doesn't matter which way around you call it, okay? But it's important, these two angles are the same, these two angles are the same. If I go to our little, this is kind of cool because we can actually, so this is in transom.org. If you want to go about and play on this, you can get your interactive stuff going on. We can see that this angle is the same as this one, which is 42. Our bottom ones are always the same no matter where we move it around. It starts to go a bit strange there, but we'll talk about that later. So it gets strange up here. But we can see these are always 49, these are always 45.
Up there, is it 360 minus 49?
Yes. Okay, these are always 64, these are always 74, okay? So it doesn't matter, okay? If you've got that same shape going on, this angle will always be the same as this one will always be the same as this one.
Wait, if it goes up there, above, then it's not.
Okay, if it's like this, I don't really like the way they set this out, okay? And we'll talk about this one separately because this is another one. But actually, if I just go back, you'll be able to see a bit better in this one. So this is the same type of thing, okay? What do you notice about the opposite angles?
100.
Yeah, they always add up to 180 degrees, okay? So this one and this one will always add up to 180 degrees. So I'd always think of it, if you see this shape, think of it like that. This one and this one will always add up to 180 degrees. And then if I do this angle is the same as this angle. This angle in here, 16, is the same as this little one in here, okay? Cool. Good. So that's some transom circle theorems. You can have a look at it. Oh, let's go back to here. So that's angles in the same segment. Sorry, I want to kind of rattle through a few of these so then I can at least give you some to practice. Angles at the center. So we'll draw our circle. Put our center point in. And you can tell me anything about this particular one.
The angle at the center
Yep.
is, what was it? Oh, yeah, the angle at the center is 2 times larger than the angle at the line.
Right. At this one?
Yeah.
Okay, so if this is x, this is
And
2x. Yes, good. So angle at center is double the angle at the circumference. These are the types of things as well. If you like cue cards, make them up, stick them on your wall, Stick them above your bed so every time you wake up you see them and they get ingrained so you do not forget them. And if I go back, sorry, I'll put it back up in a second, but here it is. So it's 120 at the center, so at the circumference it is half that, which is 60, okay? And that is always the case, okay? Yep, easy. Now if I go like this, do not get confused with this one. This is important. Tomorrow. Yes, this is not.
Sorry.
Yep, this is not the same as the TIE Fighter one, okay? Why not? Because it starts at the center, okay? For the TIE Fighter one to occur, it has to go to the circumference, okay? Each corner of the TIE Fighter, I can't believe I'm calling it a TIE Fighter, it has to go to the edge of the circumference, okay? Whereas this one, if I bring it round again, it does not, okay? So this angle does not equal this one, okay, in this case. Well, we don't know. Yeah, sorry. So if we look at it like this one is double this one. I don't want to make any... Move this one. So it is, yeah, it's actually double, yeah, it will be double, because when this is 180, this is the same. This one is double this one, because what's this one? 90. Okay? The thing is, I always look for this shape first, okay? Look for the shapes you know, and then you'll always be able to work out whatever you need, okay? Right, all good so far? All right, good. I've got a couple of sheets that I will give out, and you can have a practice at those. We will look at the others tomorrow. So that's the, I want to kind of get on to the exam one. So we've done that. We've kind of touched on this a little, okay? And we'll start doing the exam questions as soon as possible. All good?